Guys, I'm gonna discuss what I've been working on. It's called the Music Without Delay library. Code is here on my GitHub, and I'm gonna test what I've done. You can play chiptunes. You can play infinite polyphony as long as your microcontroller has enough memory and it can handle that speed. So we're gonna test it. We have a speaker. We have an app. It's called Analyzer Frequency app. Yep, that's what the app is called. I'm going to use that to prove my theory of showing polyphony. So let's get to it. We have a potentiometer to increase the volume, and we got a low-pass filter, and we're outputting sound using only one pin. So we're not using DAC. We're using high-frequency PWM synthesis. It's more complex because it's more software-related method to produce multiple notes at once. Where DACs, you make a resistor ladder and you just output sounds using multiple pins. But I thought, that's a waste of time. Just use one pin. You can use the other ones for other things like driving a motor or displaying an OLED, blinking an LED, that stuff. So I'll just increase the volume, get to it. So you can see there's 4 hills, and those are at different frequencies. 1, 2, 3, 4. Okay. So the Arduino Uno can do 8-note polyphony, but the stable version is at 4 voices. You can change that in the code. I'll show that later. But for now, let's show what the Teensy can do. This is the Teensy LC. It's a really powerful 32-bit microcontroller made by Paul Strofgen. And, oh yeah, I gotta plug this in. Alright, I plugged it in like magic. And now I'm gonna increase the volume. There's at least 30 notes playing here at the same time. It's pretty intense. Maybe we can count them all. So let's just pause it. Alright. So let's see. 1, 2, 3, 4. The thing is, it goes up way too high, and we can't hear some of the frequencies, but it's really powerful. You can change it to 30 if I wanted to. Actually, I think this is 16, because that might be some of the junk. I have to change the code for that. But it does work, and it's already pretty impressive. You're playing 30 or 16 notes on one pin. You're using high frequencies. You're just basically using one timer and just cycling through it and playing, adjusting the bits. There's 255 bits, and you're just changing each one individually. That's pretty much it. The code is pretty complex, so the hardest part is the volume control. This takes forever to do. There's also, I think I included an anti-clip algorithm, so when you hit a maximum volume, it doesn't make a cracking noise in the speaker. And there's a button here to make a little oscillating effect. That's cool. Yeah, this is just the beginning of what the library can do. There's a lot of code here. Of course, you can play music. I'll show that in the next video.